क्वेश्चन नंबर 2, पेपर 9701 52 मार्च है 2024। एक सवाल इसका हमने कल किया था। दूसरे में कह रहे हैं स्टूडेंट वांट्स टू इन्वेस्टिगेट द रेट ऑफ द of methanoate. The reaction is catalyzed by dilute hydrochloric acid. Hydrochloric acid is acting as a catalyst. The amount of methanoic acid produced as the reaction progresses can be monitored by titration with aqueous sodium hydroxide of known concentration using thymolene as the indicator. To determine this, the volume of NaOH needed to neutralize the H plus from the catalyst needs to be found beforehand. The student uses the following procedure. Step number 1 में is doing add approximately 150 cm cube of iced water. Okay, iced water to 250 cm cube conical flask. Okay, add 200 cm cube of 0.250 mole per dm cube HCl to a 500 cm cube volumetric flask, conical flask. B. Conical flask B is the flask in which the reaction takes place. Step number 3. Transfer 2 cm cube of 0.250 mole per dm cube acid from conical flask B to conical flask A. Carry out a single titration of the contents of a flask A with an NaOH of known concentration. Okay. Add 10 cm cube of methyl methanoate. Add 10 cm cube of methyl methanoate to conical flask B. Methyl methanoate is your ester. To conical flask B, swirl the reaction mixture and immediately start a stopwatch. B में आपके पास you have HCl, you know. So if you remember when we were doing an ester, so I told you okay, esters can be hydrolyzed. Esters can be hydrolyzed by like we can do acidic hydrolysis and also we can do the basic hydrolysis as well. So they are doing acidic hydrolysis of an ester. So after 1 minute, transfer 2 cm cube of the reaction mixture from conical flask B into conical flask A. Carry out a further single titration of the contents of conical flask A against NaOH. Do not empty the contents of conical flask A between the titration. After 10 minutes, transfer 2 cm cube of the reaction mixture from conical flask B into conical flask A. Titrate the contents of conical flask A against NaOH. Or then repeat step 6 at intervals of 10 minutes for 1 hour. State which step is used to determine the concentration of H plus ions from the catalyst in the mixture. यानी कि among these all steps, which is the step in which you are going to find out the concentration of H positive ion from the catalyst in the reaction mixture. Okay, so if you can see in step 1 what we did, we are transferring 150 cm cube to 250 cm cube conical flask. Let's suppose you have a conical flask which is of 250 cm cube and I'm adding 150 cm cube of iced water. And then in step 2 what we are doing, add 200 cm cube of 0.250 mole per dm cube HCl. HCl means this is the H positive ion. HCl means this is H positive ion, okay, to a 500 cm cube conical flask. Conical flask B is the flask in which the reaction takes place. So far, we didn't do anything, okay? We have not started that titration. In step 3, they are saying transfer 2 cm cube of 0.250 mole per dm cube HCl from conical flask B to conical flask A. Okay. Carry out a single titration. Now we have started the titration. So of course, in question number A, they are saying state which step is used to determine the concentration of H positive ions from the catalyst in the mixture. I would say step number 3. I would say step number 3. Okay. And then they are saying the iced water in conical flask A is used to significantly reduce the rate of reaction. Whenever you want to stop your reaction, okay, so you are supposed to decrease the temperature. When you are supposed to decrease the temperature, it means that you are supposed to, it means that you are going to decrease the kinetic energy of the particles. Of course, there would be a less number of collision, so the rate of reaction would decrease. Okay. So they are saying state two reasons why the rate of reaction is significantly reduced when the reaction mixture is transferred to conical flask A. The same thing that I told you, that temperature decreases. That's the reason. When the temperature decreases, so the rate decreases. They are asking the two reasons. Okay. First of all, I would be writing K decreasing the temperature decreases activation energy. Decreases decreases kinetic energy of the particles. Okay. Acha. Then uh, another reason, possible reason is that when the concentration decreases, so the rate decreases. क्योंकि concentration is directly proportional to the rate of reaction. Concentration means the number of particles. When the concentration decreases, so I can say the number of particle decreases. When the number of particle decreases, so you can say the number of collision decreases. So as a result, the rate would decrease. As a result, the rate would decrease. Okay. So I can say the rate of reaction decreases. So the rate of reaction decreases. Challenge. Table 2.1 shows the readings taken by the student. The titrations in its steps 4 to 7 show the volume of NaOH needed to neutralize both the H positive ions from the catalyst and from the methanoic acid produced in the reaction. So of course, more number of Na, of course, the more volume of NaOH would be utilized because it's going to neutralize the two H positive ions. The first H positive ion is coming from the catalyst and another H positive ion is coming from your methanoic acid. And where the methanoic acid comes from, of course, you have hydrolyzed your ester. You did acidic hydrolysis. That's the reason the methanoic acid is produced. Then volume of NaOH needed in cm cube to neutralize H plus from catalyst is 11.40 and volume of NaOH in cm cube used to neutralize H plus from methanoic acid at time t is Vt, total volume. Volume at time t basically. Volume of NaOH in cm cube used to neutralize H positive from methanoic acid at 60 minutes would be volume infinity. Okay. So now they are saying complete the table. The student forgot to take reading 5. First of all, have to do, we have to complete the table 2.1. So, you know, what I would doing, what I would be doing, this is your total volume of NaOH needed to neutralize total amount of H plus, that is 12.60 centimeter cube. So this is Vt, that is the used to neutralize H plus from methanoic acid. And what is this? This is the total volume of NaOH needed to neutralize the total amount of H plus. Total amount of H plus means that it is coming from HCl as well as it is coming from methanoic acid. So this is the total volume. I need Vt. I need VT. VT is what? It's purely the volume. It's purely the volume of NaOH that is needed to neutralize methanoic acid. So what am I supposed to do? What am I supposed to do? If you are going to subtract this by this, you will be getting this, of course. है ना? So देखिएगा जरा, minus 11.40, it would give you 1.20. Same goes with this. What's the answer? Yeah, this is,
6.30.
yes. And this is 8.50. This is 10.70. This is,
13.50.
then what I would be doing, um, V infinity minus Vt. Of course, V infinity is the volume of NaOH in cm cube used to neutralize H plus from methanoic acid at 60 minutes. That is V infinity. Okay. So you can see, okay, yeah. So what am I supposed to do to find out this column? Then I'm going to tell you in this. Yeah. You know, this is at V infinity, right? That is 14.50. This is at 60. This is at time 60 minutes. This is at time 60 minutes. You know, this is called V infinity. This is called V infinity. Okay, makes sense? Okay. And this is 1.20. So what I would be doing, 14.50 minus 1.20 would be equal to 13.30. Then 14.50 minus 6.30 would be equal to this. 14.50 minus 8.50 would be equal to this. 14.50 minus 10.70 would be equal to this. 14.50 minus 13.50 would be equal to this. 14.50, of course, 14.50 would be equal to, of course, 0.00. Then this would be 8.20, and this is 6.00. This is 3.80. Okay, and this is 1.00. Identify the independent variable. I told you, na, okay, independent variable means that, okay, like if you remember, let me tell you one thing. Okay, mhm, yeah, say this. So when we were doing different graphs, so at that time I told you, okay, independent variable, we can control it during experiment or we can change it. Or what is dependent variable? It changes as independent variable change. Like in simple words, we generally say concentration is directly proportional to the rate of reaction. So we can change the concentration now. We cannot change the rate. The rate automatically changes as the concentration changes, of course. So the concentration is your independent variable. Rate is depending on concentration. Rate is the dependent variable, which is always written on y-axis, and this is always written on x-axis. So what they are asking in the question, hai bhai? What they are asking in the question, the independent variable. If you can see this, they are asking independent variable. So, so can you tell me what should be the independent variable in this? Of course, we are changing the time. We are changing the time. Okay. So the time is your independent variable. Okay. Identify one variable that needs to be controlled apart from concentrations and volumes of solutions. Okay, apart from concentration and volume of solution. Since we are doing the titration, we generally do concentration and volume during the titration, but they are asking one other variable that needs to be controlled. That is temperature. That is temperature. Okay, reading 2 should have been taken. Reading 2 should have been taken at 10 minutes and not at 13 minutes. State whether this result should have been included or not. Explain your answer. Reading 2, reading 2 should have been taken at 10 minutes because all the readings are, you can see, 20, 30, 40, 50, 60. So why this is so? So why this is so? They're saying reading 2 should be taken from, should have been taken at 10 minutes, okay, and not at 13 minutes. State whether this result should have been included or not. Explain your answer. Okay. So what do you think? Yeah. You know, if you can see the value of the titer, if you can see the value of the titer, this is 12.6, this is 17.7, this is 19.9, 22.1, 24.9, 25.9. The values are increasing. The values are increasing. It's not anonymous value. It's not a random value. It is matching with these all. So that's the reason I would say कि yes, this this is accepted value. क्यों? क्योंकि as the value of titer, as the value of titer, as the value of titer, okay, is correct. As the value of titer is correct with respect to, with respect to its time, with respect to its time. Otherwise, if this value couldn't be like let's suppose if this value couldn't be taken at you can say 13 minutes, so so the result should be random. But but interestingly, we have taken the value at 13 minutes. In spite of this, we are getting the same. We are getting the constantly continuous value. You know, increasing order. Okay, like होना तो ये चाहिए था, ये आ जाता 10 point something. Okay, like first increase, then decrease, then increase, then increase. But no, this is following a regular trend. So this value should be taken in account. This value should be accepted on the basis of this. Okay, plot a graph. Plot a graph on the grid in figure 2.1 to show the relationship between this and time, use a cross to plot each data point, draw a line of best fit. Draw a line of best fit. Okay. Uh, V infinity minus VT. Like we have to consider these values. These values. Okay. So let's just start it from 0.00 and the time is and the time is 60 and the time is 60. Okay. So I got the first value, that is this. Okay. Then they are saying at 50 minutes the value is 1. At 50 minutes the value is 1. This is the another value. This is 1, this is 2, this is 3, this is 4, this is, oh no, man. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11. Okay. This is 12, this is 13. So, like at 50 minutes, the value was 1. And then the third value says at 40 minutes, there is no any value. Okay. And at 30 minutes, the value is 3.80. So at 30 minutes, 3.80. So this is 3.2, 3.4, 3.6, 3.8. So I got another value, that is this. Okay. And then at 20 minutes, the value is 6. At 20 minutes, the value is 6. Then at 13 minutes, the value is 8.2. At 13 minutes, this is 12, this is 15, 25, 35, 45, 55. At 13 minutes, the value is 8.2. Okay. So 11, 12, 13, 11, 12, 13. So at 13, okay. Then at 1 minute, the value is 13.3. At 1 minute, at 1 minute, 1 minute is this. The value is 13.3. Okay. 13.1, 13.2, 3, 4. 13.2. This is okay. These are the values. ये पूछ रहा क्या है कि draw a line of best fit. Draw a line of, you know, people think that the line of best fit is always a straight line. No, no. It may be a curve. Maybe a curve, okay? Maybe curve basically. Okay. Reading 5 was not taken. Use the graph to predict.
The total volume of NaOH needed to neutralize the total amount of H plus at 40 minutes. At 40 minutes. So I can say at 40 minutes, 40 minutes, it may be like that. That is 2.20. That is 2.20. That is 2.20. Okay. So, of course, I would go to the table. I would go to the table. So, 2.20. 2.20. So, 11.4 plus 2.20 would be equal to, no, it's VT basically. 11.40 was the value. Okay. Huh. Can you tell me 11.40 plus 2.20 would be what? Yeah,
13.60.
13.60.
60.
So if this is 2.30, 2.0, or this was 14.5. Okay. Uh, so what the value we got from the graph? 2.20, na? Okay. Okay, 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 okay. So 14.50, 14.50 minus का 12.30. What's the answer? What's the answer? Yeah, what's the answer? 14.50 minus 12.30,
2.2.
2.30. Okay.
No,
So
sir,
if this is,
2.20.
it's 2.20.
Yes, sir.
Okay. So I can get it from, can you subtract it? Are you getting this value?
Yes, sir.
12.30, right?
Yes, sir.
Okay. So exactly this was 23.70. Exactly this is 23.70 centimeter cube. 23.70 basically. Because you got, 2.20 is the value of this. 2.20 is the value of this. Okay. So V infinity and minus VT. V infinity and minus VT is 2.20 that you got. Okay. So of course it can be 14.50 was the V infinity. Okay. So 14.50, 14.50 minus 2.20. What's the answer? What's the answer? Yes,
2.30.
12.30.
Yes,
Yes.
sir.
So that's
Yes,
the
sir.
reason I got this value, 12.30. I got this value. And when I got this value, 12.30, of course, that can be obtained by the I have subtracted 11.40 from all. So 12.30 plus 11.40, I would be getting 23.70. So it's a chain basically. Okay, so that's why I have written 23.70 centimeter cube. It's not possible to repeat the experiment. State whether the data from the experiment is reliable. Justify your answer. Justify your answer. Of course, the data is reliable. All the points are lying on the plane, on the best fit line. Of course. Yes, yes, the data is reliable. The data is reliable. Why? As all the points, all the points lie on the best fit line. Okay, that's it.